All right, so what we are talking about today is trigonometric ratios. So to kind of, before we can really like understand exactly what those are and be able to use those, we kind of have to talk about what does really trigonometry mean, okay? So trigonometry is essentially just the study of the measures of triangles. If you actually just break down the word trigonometry, it means trigon means triangle and metron means measure, okay? So it's just triangle measures, right? So don't be scared of the word or anything like that, okay? So, what a trigonometric ratio is just the ratio of lengths of any two sides of a right triangle. And that's it. That's all they are. Okay? So imagine if I have a right triangle here. Okay, so if I have this right triangle, for example, okay, then if I just kind of extend one of the sides, or two of the sides rather, and I keep the angles the same, so any one of these triangles, right, that are now created, these bigger triangles, right, they're all going to be similar, right, by angle-angle similarity, because they're all essentially using this angle here, and they all have a right angle. Okay, so essentially all right triangles with the same degree measures are similar, which means that their ratios are always going to be the exact same. Okay, so before we really kind of move on even further, there's a phrase that I kind of want you guys to remember or memorize, and this may be a phrase that you've heard before. It's so ka toa. Okay. All right, and you'll understand what this means very, very soon. Okay. So the way it's spelt is the important part. You have SOH, CAH, and TOA. Okay. So, all right, there are three primary trig ratios. Okay. We have is sine, we have cosine, and we have tangent. Okay. You'll see these on your calculators as SIN, COS, and TAN. Please know that we do not say these as sin, cos, tan. Oh, I'm supposed to be screen sharing. I am so sorry. I forgot. I apologize, those of you on Zoom. You guys can see it now, right? Okay, I apologize. All right, anyway, kind of going back. So we have the three trigonometric ratios, which is sine, cosine, and tangent, not sin, cos, tan. Okay. Now what sine is, right? It's the ratio between the leg opposite the angle and the hypotenuse. Okay. What cosine is the ratio between the leg adjacent to the angle and the hypotenuse, and then what tangent is the ratio between the leg opposite the angle and the leg adjacent to the angle. Okay. So we're just going to focus on understanding what that means, right? Using this triangle right here. Okay. So the way that we write each of these trig ratios or identify them is we always write something like sine of A is equal to a ratio. Okay. And what that means, right? This guy right here, right? This is what we call our reference angle. Okay, so essentially this is where we're standing. So for example, of sine of A, right, imagine I'm now standing at A. Okay, I'm standing at A, so at my reference angle. Okay, and when we say sine is the ratio, right, between the leg, right, opposite, right, and the angle and the hypotenuse, right? That means if I'm standing at A, okay, and I'm looking into the triangle, okay, I'm looking into the triangle, okay, C will always be my hypotenuse, right? This will always be my hypotenuse, right, because it's the side opposite the 90 degrees. Okay, so when we say it's the ratio between the side opposite, right, if I'm standing here at A, this is my opposite side, right, which is A. So it's the side that's directly on across. So in this case, since this one has a measure of A and this one has a measure of C, my ratio, so sine of A, is opposite over hypotenuse, or A over C. Okay. Now, and again, that's kind of what we mean when we're talking about SOHCAHTOA. Okay? So the way that I kind of want you to think about this, and I'll even get rid of this thing here, right? What it's spelling out is telling you how the things go. So for this one, it would be sine is opposite over hypotenuse. Right? So another way of thinking about sine, right, is equal to opposite over hypotenuse. And again, I actually think I have that down here in the corner. No, I don't. Okay. So again, SOH, sine opposite hypotenuse. Okay? Now for cosine, right? So the cosine is the ratio between the leg adjacent to the angle and the hypotenuse. What does adjacent mean again? We've talked about adjacent angles and stuff like that before, but what does adjacent mean? Oops, sorry. What's adjacent mean? It means next to, okay? So, in this example, if we want to find the cosine of A, right? My reference angle is still A, so I'm actually still standing here at A, okay? And since the big A, I guess the angle A, and so since this was the opposite side, the one that's going up towards A, my adjacent side would be the one that's next to, right? So it would be right here. So in this case, it would be adjacent. And you're probably thinking, why isn't the other side adjacent? Why isn't the long side the adjacent side? Because the long side is always the hypotenuse, no matter what. Okay? So in this case, if I'm trying to find the cosine of A, right, the cosine is the ratio between the adjacent and the hypotenuse. So the adjacent side is B, right? And the hypotenuse is still C. It would be B over C. Okay. And so again, for SOHCAHTOA, right? So now you can think of this as cosine is adjacent over hypotenuse. Okay? So that's kind of what this means. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then we'll get to tangent in just a second. So another way here, cosine of A would be adjacent over hypotenuse. This is why I wanted you to print these out, because there's kind of a lot of stuff that we're adding to them. Okay? All right. And now for tangent, right? The tangent is now the ratio between the leg opposite to the angle and the leg adjacent to the angle. Okay? So like I'm sure you can imagine up here for the TOA, right? We're now going to have tangent is opposite over adjacent. Okay? So if I want to think about writing a ratio for tangent of A, it would be the leg that is opposite over the leg adjacent. Okay? So let's kind of go back to our diagram. Okay? And so now we're trying to find tangent of A. Right? So again, we're still using A as our reference angle here, so I'm still standing at A. Okay? And so now we want to go opposite side. Well, the opposite side, in this case, is A, over adjacent side. Now my adjacent side is this one, which is B. So it would be A over B. Okay? So now I'm going to give you about 3 minutes, and I want you to try and fill out the rest of this table. I want you to think of, okay, I want you to try to figure out what sine of B is, what cosine of B is, and what tangent of B is. I'm going to give you about 2 minutes for that one. And then I want you to rack your brains a little bit on this one because this one's tougher. Sine of C, cosine of C, and tangent of C. Okay? And again, I have a little diagram over here to the right, which kind of helps explain it just as well if you use X, Y's, and Z's a little bit better instead of always using A's. But this is just kind of an example. But I want you to use this diagram, and I want you to try. I have to zoom out a little bit. I want you to try and tell me what sine of B, cosine of B, tangent of B is, and then sine of C, cosine of C, and tangent of C. Okay? All right. So who can tell me what sine of B is? Yeah. Yeah. You. What? B over C? Perfect. So sine of B is B over C. Okay, and the way that we get that is now, right, our reference angle, right, is B. So I'm actually standing here at B. Again, when I say reference angle, we're always looking into the triangle. Okay? So my reference angle is B. So I'm standing at B, and what's the side that's opposite B? B in this case. Okay? So it'd be B over the hypotenuse, which is always C. So it'd be over C. What about cosine of B? Give someone else a chance. What's cosine of B? Anyone on Zoom, maybe? All right, Mason, what's up? What's cosine of B?
B over C.
B over C. Okay, so cosine of B, right? Cosine of B, remember, is adjacent over hypotenuse. Okay? So if it's adjacent over hypotenuse, what's the adjacent side? Right? Because we already said B was the opposite side. All right, so it'd be A, right? So it's not, the adjacent side would be A in this case, and then my hypotenuse is still always C. Okay? So cosine of B is A over C. Now what's tangent of B? All right, go ahead. B over A. So opposite over adjacent. Perfect. Okay? It'd be B over A in this case. Okay. All right. So a couple things that I want you to take note of, and I'm not going to spend a ton of time, and usually if we had more time in the year and stuff like that, I would make a big deal about this and we'd kind of talk about this. But I just want you to kind of look at these two and these two. What do we notice? Cosine of A and sine of B are what? Exact same values. Okay? However, A and B are not necessarily the same degree measure. Right? And why that works is because they're complementary angles. Okay? But again, I'm not going to spend a ton of time on that this year. But it's just something I really want you to kind of notice, but we're not going to make it a big emphasis. Okay? So now let's talk about sine of C. This is where it's going to get tricky. Okay? So, C, what angle measure is C in this case? The big C. What angle measure is it? So it's the 90-degree angle. So when we're looking at sine of C in this case, all right, we already know what this angle measure is. Okay? So, sorry, I don't know why I did that. So sine of C is the same thing. We're saying, well, this is the sine of 90 degrees. Okay? But what sine? What's the ratio for sine? It's opposite over what? Remember your phrase. Sine is opposite over hypotenuse. Yeah, Christian. Yep, hypotenuse. Okay? Now, what's weird about this case? Right? So I'm going to go ahead and I'm going to erase all this stuff here. Right? So now I'm standing over here at C. Right? This side right here is still my hypotenuse. But what's the side that's opposite C? It's C. Okay? So this is not only the hypotenuse, right, but this is also my opposite side. Okay? So sine of 90 is opposite over hypotenuse, which is C over C, which is just 1. Okay? It's 1. Sorry, I'm not writing that very well. Okay. Now what about cosine of C? This is where it starts to get a little bit funky. Okay. Which of my sides are adjacent? XY sides are adjacent to C? Say what you're thinking. Okay, A is one of them. But the problem is so is B, isn't it? Yeah. Right? Because remember, when we talk about opposite or adjacent, right, or adjacent anyway, we're saying the leg that's not the hypotenuse that makes up the angle. But the problem is both of these are legs that don't make up the hypotenuse. Okay? So when it comes to 90 degrees, right, there's a special kind of case here. Is because we have to choose between two different legs, right? We choose none of them. So if we ever have to choose between two of them, we choose none of them. And so we actually get nothing over C, which is just 0. Now tangent's even weirder. Okay? So tangent is opposite over adjacent. So tangent of 90 degrees is opposite, which in this case we said was C, over my adjacent side, which was what we just said was 0. So what's any number divided by 0? It's not 0. Just try to think about this. Try to take this, divide this up into 0 amount of pieces. Can't happen, right? But I can take 0 and divide it up into 5 pieces, can't I? So 0 divided by any number is 0. But any number divided by 0 is what? Who remembers? Yeah? Mm-mm. Mm-mm. Keep trying. Those are good guesses. Sorry. Undefined. Okay. Undefined. So, just kind of a little, I'm going to put that little side note here. Yeah, I'll use purple. All right. Any number over 0 is equal to undefined. And any 0 over any number will always be 0. Okay? All right. So now, I know I'm kind of pushing your brains here a little bit, but we're going to take it another step farther. Now, I want you to try to do the same thing. I'm going to give you about 5-10 minutes on this one. Okay? I'm going to give you about 5-10 minutes on this one. I'm actually going to stop the video here, and I'm going to start a second video to record for after. I want to give you about 5-10 minutes to see if you can't use the special right triangles that we talked about before, 30, 60, 90, and 45, 45, 90, and see if you can't come up with ratios for all of these. Remember, okay? So another thing that you kind of want to think about, okay? The other thing is always simplify. Okay? Or reduce. Okay? Always simplify or reduce if you can. Okay? So I'm going to give you about 5-10 minutes to work on this. For the video's sake, there will be a second video that kind of talks about this in the last example.